Hi everyone, I'm Abhisha, the sole developer of SignBridge, and here on we'll be presenting my showcase for the Creator Coliseum Hackathon. And so, what is SignBridge? SignBridge is the creation of my ambition of learning ML, and also a creation of myself wanting to do something good for the society. So now let us head over to the technical area of how the SignBridge actually works. So the problem statement is that it is trying to solve the communication barrier in classroom for deaf or hard of hearing students. And the reason for this is that the current solutions are very expensive and require very hard and complex models to be work properly. Now, what I have done is that I have developed SignBridge using the common Python programming language and using the library of MediaPipe and generally opencv for the computer vision area. Now what I have done is that I have trained the model using 21 MediaPipe hand landmarks for the static area and for 21 into 16, that is 21 landmarks spanning through 16 frame gestures for the entire motion area. I have made two different models. One is the static model and the other one is the motion model. Both are for different things, as the more complex motion thing, such as the J and Z, require a lot of motion, whereas A, H, and most of the sign alphabets require not that much motion, but more of the static area, including the common hand gestures of good, bad, and others. So, how the system works is that it takes the feed from the webcam and then it takes the feed of the webcam and then runs it through the MediaPipe hand landmarking. Then it loads both the model together, that is both the static model and the motion model, and then separates those into 4 and 3 chunks so that both the model can give their prediction, and based on which model has the higher prediction, we use that via the confidence gating. That is, we have a fallback logic so that no model overwhelms the other. Now, what are our optimizations? We have done the basic frame skipping so that instead of checking every frame, we check every second frame. We use an MJPEG web camera that reduces the random shutter. Similarly, what are the performances? We get about 125 FPS without any hand, 75 FPS during hand detection, and 3 to 4 FPS when both models are loaded, because the motion model needs a lot of system resources, and this is entirely done on a low-end system. Now, what are the current limitations? The current limitations is that the models are only trained based on 7 signs, that is 4 static and 3 motion, and it's a single cell dataset. We need a multi-cell dataset to reduce bias and others, but that is in later on. That is what I have built versus the future work. So let us go over to the how this actually works. Now, as seen, this is giving me over 170-65 FPS. So let us go over to the prediction area. And hello, as I've seen, as I've already told, this is the motion area. This is the motion part. And similarly, if I do this will put the static. Good. Similarly, if we go down, this is bad. Now, about the more motion complex, that is the Z and H. This is the Z, and about the J. This is another limitation, that sometimes the motion model requires a lot of help, but yes, it eventually gets the J. Others are the common H and the A. A. And it works for both the hands. Currently, it is only built to work on only one hand, but we'll later on integrate multi hands so that the overall resources can be more nicely done. And with that, I would like to end this showcase. and thanking everyone and thanking all the judges for being here. Please check out this project. This is in work of my intervention to learn and also develop my skills for the future. And I'm the entire developer. So thank you and have a nice day ahead.